We've seen a few data definitions so far, including intervals and enumerations, and what we're going to look at now is a generalization of the notion of those two types of data definitions, and we're going to call this an itemization. And in general, an itemization is when you have a data definition that sets up or it includes two or more possibilities. Okay, so let's look at a context. Suppose we've got a slightly fancier representation of grades on assignments, and we'd like to capture the notion that a grade on an assignment could be either a numeric value between 0 and 100, or it could be missing or excused. And if a grade is missing, then it counts as 0 when we are averaging things up, and if a assignment is excused, then that assignment is not included in the course average, but it's not necessarily considered a failing grade. So given this context, let's design a data definition for representing grades. So it looks like we've got a few possible things that a grade could be. So it's either a number in some interval, or we want to indicate that the grade is missing or excused, and we could use literally the string missing or excused. If we wanted to, we could use some sort of negative number maybe, or maybe some Boolean values to represent these other cases. But just to keep things more intuitive, I'm going to go ahead and just use those strings to represent the state of the grade in those situations. So I'm going to define a grade as being one of either a number in the interval 0 to 100, or it's going to be literally the string missing, or literally the string excused. Okay, so that's my types comment. I'm going to write out an interpretation. So an assignment grade in a course. And now let's write some examples here. Okay, so itemizations in general are not necessarily or not always going to be as trivial as enumerations, and so it will help us, especially as we develop more fancy itemizations, to have some examples. Okay, so let's say missing. So here's a few examples of what grade might look like. The number 95, 78, so these representing numeric values, or we might want to indicate that a particular grade is missing, and for that we'll use the string missing. Okay, so now how do we form the template? Well, we're going to name this grade func, takes a grade. And just like intervals and enumerations, since we've got one of several possibilities, you've probably already guessed that this is going to have a conditional. And now to define this conditional, we've got to have ways in the question parts here to isolate each situation. Now, how might we do this? Well, we notice that grades can actually be one of two types of data. They might be numbers, or they might be some strings. Okay, so we need a way to distinguish when this grade value right there is a number versus when it's a string. And so for that purpose, we are going to use the appropriate type predicate. So the first thing I'll do here is, I think what I'll do is just see if the grade is a number. Okay, and so if the grade is a number, then over here we will just put a grade in dots, and this will handle the case when the grade is a number in the range 0 to 100. In this case, since there's only one interval, I'm not going to explicitly check the interval itself to see if the grade falls into that interval. I'm just going to assume that if it's a number, we've been given a valid grade and it's going to be in that interval. If we had multiple intervals to consider, then we might have to check that the grade is a number and that it falls, say, between 0 and 100. Okay, so we might have to use a compound condition there in that situation. All right. So if the grade is not a number, then it's got to be one of these two strings, and now we've got to distinguish between the two strings. So for that purpose, we're going to use the string equality operator, and I'm going to check to see, is the grade then the string missing? Okay, in which case if it is, we'll fill something in on the right hand side, and over here is the grade then excused. Okay, and if it is, we'll fill in something here. So I'm not going to put a grade on the right hand side of these because, again, kind of like with enumerations as I mentioned, if you get to this particular case, then you know exactly what that grade is. It's literally the string missing. Beyond knowing that the grade is this string, there's not much more useful information you'd be able to get out of it. Whereas if it is a number, you might be needing to do something with that number further, such as adding it into a course average or something like that. And for that reason, over here on the right hand side of this clause, I do include the grade in dots. Okay, so that there is the template. All right, so to review an interval, a data definition that just consists of intervals, it distinguishes different subclasses or ranges of numbers. And enumeration specifies distinct individual elements from some existing class of data, usually strings. And what we've just seen here is what we'll call an itemization. It generalizes the two previous types of data definitions, and it allows combining any existing classes of data, any existing types of data that have already been defined with each other and kind of giving them this this name that refers to any of those possible values. And sometimes we're going to use the name, you might hear me use the term mixed data, okay, for itemizations. And so just so you are aware, I might use that term mixed data to refer to itemizations. It means the same thing, okay? We're talking about the same type of data definition. And like the other data definitions we've looked at recently, the template for itemizations consists of a conditional expression with as many clauses as there are cases in the data definition. And the question portion of each conditional clause should isolate the corresponding case of the data definition using comparison, equality operators, or type predicates as necessary.